Hey everyone, and welcome back. We're going to be diving deep into large language models today.
Oh, yeah.
Specifically, a new architecture called DeepSeekMoE.
Okay.
Now, this is probably something you're interested in because, LLMs are like behind everything nowadays, right?
Yeah.
Chatbots, text generation,
Yeah, all that.
all that, and this architecture could make them even better.
Even more powerful and efficient.
Exactly. More powerful, more efficient.
Yeah.
We're looking at excerpts from a research paper today. It's called DeepSeekMoE, towards ultimate expert specialization in mixture of experts language models.
That's a mouthful.
Yes.
But the interesting thing is they're tackling a problem with LLMs. Like,
Yeah, what's that?
as they get bigger, they need more and more computing power.
Yeah, and that gets expensive
Oh, yeah, super expensive.
if you don't have those big Google-level resources.
Exactly. So that's where this DeepSeekMoE comes in.
Oh,
It uses this thing called mixture of experts.
MoE.
Yeah, MoE.
Yeah.
It's like having a team of experts instead of one giant brain.
Okay, so instead of using every single expert for every single task, you just activate the ones you need.
Exactly. That's the idea.
Summer.
Yeah, but what makes DeepSeekMoE different is it takes this MoE even further with two things.
Two key innovations, you're saying?
Yeah,
Okay, I'm listening.
they have fine-grained expert segmentation
Fine-grained expert
and
segmentation.
shared expert isolation.
Okay, those sound kind of complicated.
Yeah, maybe a little, but fine-grained expert segmentation. It's
Or
like,
break it down for me.
imagine instead of a general doctor, you have a bunch of specialists,
Okay.
like a heart doctor, a brain doctor, all that.
Makes sense.
So the knowledge is broken down even more, you know, more flexible.
So you're getting the right expert for the job.
Exactly.
I like it. And what about this shared expert isolation thing?
So think of it like
Yeah.
there's always some basic knowledge you need, right?
Yeah, like common sense stuff.
Exactly.
Yeah.
So DeepSeekMoE isolates some experts that are always active for that basic stuff.
So like a core team that always knows the basics.
Yeah, and then the other specialists can focus on the really niche stuff.
Okay, that makes sense. But does this actually make it work better?
That's the exciting part it does.
Oh, really?
Yeah, they tested it against other MoE models like G-Shard,
Uh-huh.
and even with fewer parameters, DeepSeekMoE did better.
So it was more efficient?
Way more efficient.
Wow, okay, impressive.
Yeah, and they didn't stop there. They compared it to a dense model.
What's a dense model?
It uses all its parameters for every task.
Oh, so super inefficient.
Yeah, and DeepSeekMoE was almost as good as this dense model that was 16 times bigger.
No way.
Yeah, but using way less resources.
That's incredible.
Yeah, it is.
But hold on, how do we know these experts are actually specialized? Could they just be copies of each other?
Good question. So they actually ran an experiment where they turned off some of the top experts.
It's like taking the best players off a team.
Exactly. And when they did that with DeepSeekMoE, the performance dropped a lot.
Oh, so each expert was important.
Yeah, they were all playing a unique role. And then they tried removing the shared expert, that core knowledge base.
What happened then?
Things tanked, performance went way down.
Oh, wow.
So that core knowledge is super important.
Okay, so specialized experts and a good foundation are key.
Exactly.
Got it. And they scaled this thing up, right?
Oh, yeah. They made a DeepSeekMoE with 16 billion parameters.
16 billion.
It still outperformed a Dent model with 7 billion parameters.
So still more efficient even when it's huge.
Yep, that's the beauty of it.
Okay, so DeepSeekMoE is like a real contender now.
It's changing the game.
Definitely. But I always want to know more, what about chatbots?
Well, they made DeepSeekMoE Chat 16B,
Oh, a chatbot version.
and it actually worked really well.
Really?
Yeah, which is surprising because MoE models haven't always been great for chat.
Interesting. So they figured out how to make it work.
It seems like it.
So that's huge for conversational AI.
Oh, yeah. It could change everything.
I'm excited to see where this goes.
Me too. And they're already working on a 145 billion parameter version.
145 billion?
Yeah, DeepSeekMoE 145B.
This is getting wild.
It is. And early results say it could be as good as a 67 billion parameter dense model.
Okay, now that's a big leap forward.
It really is.
I can't wait to see what comes next.
Me neither. This is just the beginning.
Yeah, there's so much more to talk about.
Definitely lots to unpack.
All right, well, we're going to take a quick break, and then we'll be right back with more on DeepSeekMoE.
Sounds good. You know, it's amazing to see all this research changing how we think about LLMs.
Yeah.
But it's still early days, right? There's always more to learn.
Oh, definitely. Especially with AI, it feels like things are changing constantly.
Absolutely. And one thing they talk about in the paper is how complex the training is,
Yeah, makes sense.
especially for chatbots. It's not as easy as with those big, dense models.
So even though the architecture itself is cool, there's still work to do on the training side.
Exactly. Finding the right techniques is key.
Yeah.
Now, something I found really interesting was how they trained DeepSeekMoE on different languages.
Oh, yeah, the multilingual stuff.
Yeah, like they used a lot of Chinese text.
Hmm. I wonder if that changes how the model learns.
That's what I was thinking. Like, does it become more adaptable overall, or is it just good at translation?
That's a great question.
Yeah, because some researchers think multilingual training leads to like a deeper understanding of things.
Oh, wow. So it's not just translating, it's actually like understanding the concepts across languages.
Exactly.
That's pretty amazing.
It is, and the paper shows DeepSeekMoE did really well on Chinese benchmarks.
Oh, so it could actually generate text and answer questions in Chinese.
Yeah, it was pretty fluent.
Wow. It makes you think about the future of communication, you
Oh,
know?
yeah, for sure.
Like, could LLMs break down language barriers completely?
It's definitely possible. I imagine talking to anyone in the world without any language problems.
That would be incredible.
It would.
Okay, but let's go back to the technical stuff for a minute. The paper also talked about the challenges of actually training these huge models.
Oh, yeah, it's a massive undertaking.
Like, you need the right computers, the right software, tons of data.
Like a giant puzzle trying to make all the pieces fit.
Yeah, and the researchers had to get creative with how they trained DeepSeekMoE.
Yeah, they had to distribute the training across multiple GPUs, manage all the data, make sure it didn't crash.
It's pretty incredible when you think about it.
It really is.
Like, this is cutting edge stuff.
Absolutely.
Okay, but it's not just about generating text, right?
Right.
What about things like writing code or solving problems?
So they actually tested DeepSeekMoE on some coding benchmarks.
Oh, cool. Like what kind?
Things like Human Evil and MBPP.
Okay. And how did it do?
It did really well.
So it could write actual working code.
Yeah, and remember, it was still more efficient than those bigger models.
That's really impressive.
It is. It could change how we develop software completely.
Yeah, I can see developers using it as a coding assistant.
Exactly, helping them write code and debug stuff.
Yeah, that's amazing. And what about reasoning? Can it solve problems logically?
So they tested it on things like GSM-8K, which is like math word problems,
Oh, okay.
and math,
Yeah.
which is more advanced math problems.
Did it pass?
It actually showed a lot of improvement, especially compared to other MoE models.
So it can actually reason logically?
It seems that way.
Wow, that's a big deal.
It is, especially for tasks that need context and step-by-step thinking.
Okay, so DeepSeekMoE is really exceeding expectations.
It really is, but like I said before, this is still early research.
Right.
There's so much more to learn about how these models reason and how to make them even better.
It feels like we're just scratching the surface.
Yeah, exactly.
That's really exciting.
It is, and it's not just about the technical stuff. It's about what this means for the world.
You're right. It's about making a positive impact.
Exactly, and that's why these discussions are so important.
Yeah, for sure.
We need to think about the benefits and the risks and make sure AI is used ethically.
I agree 100%. It's pretty amazing what they've accomplished with DeepSeekMoE.
It really is.
But one thing that keeps coming back to me is the scale of these models.
It is mind-boggling.
Billions of parameters, hundreds of billions.
Yeah, it's hard to even imagine.
Exactly. So I'm really curious about how they actually train something like this.
Yeah.
The paper mentions some of the challenges, but I want to dig deeper.
Well, training these huge models, it's like a monumental task.
Yeah.
You need powerful computers, of course, but it's more than that.
Oh, really?
It's like you need a whole ecosystem for this
Okay.
specialized hardware software. You need to handle all that data, all that computation.
It's like building a rocket ship, almost.
That's a great way to put it.
The bigger the rocket, the more complex it gets.
Exactly. And the team behind DeepSeekMoE, they had to come up with some really creative solutions.
Like what?
They had to figure out how to distribute the training across multiple GPUs, manage the data flow, make sure the whole system didn't crash.
It's amazing they can even do this.
It really is a testament to their expertise.
Definitely. And it makes you wonder what's next, you know.
Oh, yeah. Where do we go from here?
What are the next steps for this research?
Well, one area that I'm really excited about
Yeah.
is finding better ways to manage these expert mixtures.
Okay.
Like, imagine systems that can dynamically select and combine experts.
Oh, wow. So instead of having fixed teams, the model could adapt on the fly.
Exactly. Choose the best experts for each situation.
That would be amazing.
It would make them so much more efficient.
Yeah.
But there's another thing I'm really interested in.
What's that?
Combining LLMs with other types of AI,
Oh, interesting.
like computer vision or robotics.
Yeah, could you give me an example?
So imagine AI systems that can understand language, see the world, and even take physical actions.
Okay.
That could revolutionize so many fields.
Yeah, like what?
Robotics, autonomous vehicles, personalized healthcare.
It's mind-blowing to think about.
It is. We're talking about a whole new era of intelligent machines.
Machines that can really interact with the world?
Exactly. But as we go further down this road, we need to be careful.
Right, it's not just about the technology itself.
It's about what it means for humanity.
We need to make sure AI is used for good.
Absolutely. And that's why these conversations are so important.
To make sure we're all on the same page.
Exactly.
Well, this has been an incredible deep dive.
It has.
We've learned so much about DeepSeekMoE.
From the technical details to the bigger picture.
And I hope our listeners are just as excited about this as we are.
I hope so.
If you want to learn more, definitely check out the research paper.
Yeah, it's worth a read.
Dig into the details. Think about the implications. Share your thoughts.
The future of AI is something we'll shape together.
And on that note, we'll wrap up this episode of The Deep Dive.
It's been a pleasure.
Until next time, keep those minds curious and those questions flowing.